The Earth. It's been here a long time. That we can all agree on. Whether you believe in a Big Bang theory and a cosmic pinball-like chance that the Earth would form, or whether it was created and put in orbit by intelligent design, isn't something we're really going to cover here. What we are going to cover are the processes the Earth undertook to create continents, oceans. And I think it's best we start by allowing the scientists to explain their point of view in their own words.
Flying past the Earth at this time, we see a vast gray ocean beneath a red-tinted sky, punctuated by volcanoes and small land masses. And unlikely as it seems, life may have gained a foothold already. That life in the oceans that gave birth to it may actually be vaporized many times by cataclysmic bombardments, which have slowed but not yet stopped. Earth has begun to take on its final form, a crust, a skin so thin it would be less than a sheet of paper were the Earth the size of a basketball. And under that, a molten semi-solid mantle that boils in extreme slow motion.
Okay, so what you're saying is we got a sun in the middle of our planet, kind of like this. And it's really hot, so it's bubbling around and moving kind of like this. And then on the outside, there's like a thin crust as thin as a piece of paper that's holding it all inside without exploding. Okay, all right, got it. Okay, you can continue now. Just want to make sure I'm on the same page with you.
And finally, two cores. A liquid iron core pulsing out a magnetic field that helps shield us from a deadly cosmic wind from our sun. And a solid nickel and iron inner core.
Two inner cores, I don't want to spend a whole lot of time on that because that's a whole nother subject, like how did a core become solid iron and liquid something schwitty when all this different material supposedly was smashing into the planet making the core. It's a little bit confusing to me because when you smelt something you have to have it skimmed off or released. And if you got a piece of paper enveloping the planet, I don't understand where this stuff goes, but that's why. You're the scientist and I'm just a dunderhead who went to public school. Okay, let's continue.
By now, the remarkable process of plate tectonics has kicked into gear. Though how and when it started exactly, we do not know.
So you know how the Earth was formed, but you don't know how your theory started with tectonic plates. Okay, just making sure I'm still following you. Go ahead.
The force driving the plates is the slow movement of the super-hot semi-solid mantle that lies below the rigid plates. Like hot soup, magma boils in slow motion. Superheated magma rises to the surface, begins to cool, and then sinks back down to the bottom of the pot, where it is reheated and rises again. This cycle is repeated over and over to generate what scientists call a convection cell, or convective flow.
So again, we have our sun underneath our paper, and it's like a pressure cooker under there because it's not letting anything out, and all the plates are sliding around on this mantle. Okay.
Here's how it might have happened. At first, Cretans and one continent called had the planet all to themselves.
Okay, so you have these two island continent, small ones, by themselves on the planet, which I suppose means the rest of the planet's covered by water. Okay, I don't understand where all the water came from, but alright.
Then, around 500 million years later, Antarctica took shape. About another 500 million years passed before Atlantica formed. The continents roamed separately until, about 1.8 billion years ago, Antarctica collided with what is now Eastern Antarctica to form Nina. Then Nina, Atlantica, and collided 1 billion years ago, forming the supercontinent Rodinia. About 300 million years, the three landmasses separated and came back together in a new configuration, Pangaea. Pangaea came apart too. When Pangaea split, and Atlantica split up too. If you're confused, join the club.
Yeah, lady, we're all a little confused because you ran through that last part a little fast, but okay, so if the plates are all sliding around, why don't we just summarize this and so we can move on then.
So what does this mean at the surface? Two things. First, magma being burped up along the ridges. Those places like Iceland where the Earth is tearing itself asunder is pushing the plates in their respective continents apart. Second, what goes on at the other end of those plates, the collision zone, may be equally important. Here, where the heavier plates dive under the lighter ones, yanked downwards by gravity, they haul along their plates back into the oblivion of the mantle. That's what we know, or what we think we know.
Okay, so this is basically what you're saying is these plates move around and they bump into each other, and when they do, one goes subducting under the other one, and that's how we get mountains, because they're all like sliding around on the mantle that's constantly being created, and it doesn't get any bigger, any smaller. It just changes places and it kind of moves around. Alright. Okay, so to summarize with pictures, because I like pictures, Pangaea was started breaking apart, kind of looked like this, and then it turned into this, which is more or less representative of the world that we know today. And these are plates that just kind of slide back and forth on top of a mantle with all this pretty blue water around it. And the land masses really haven't changed shape, and really the surface area really hasn't changed